make the example more concrete, let n equals 3, then the linear systems are the following. X sub 1 plus 2x sub 2 plus 3x sub 3 equals 1, 2x sub 1 plus 2x sub 2 plus 3x sub 3 equals 1, and then 3x sub 1 plus 3x sub 2 plus 3x sub 3 is equal to 1. Then the solution is x sub 1 equals x sub 2, which is equal to 0, and then x sub 3 is equal to 1/3. Thus, for the linear equations of order n, A is equal to the matrix or the numerical coefficients of the linear systems, B is equal to the constants of the systems, and X is the solution of the systems. Right. To know whether the system is solvable or not, we need to satisfy the conditions given in the solvability theory of linear systems associated with A. This is the solvability theory of linear systems. Let n be a positive integer and let A be a square matrix of order n. Then the following are the equivalent statements about the linear system. Statement number 1, for each right side B, the system has exactly one solution x. Statement number 2 states that for each right side B, the system has at least one solution x. Number 3 statement, the homogeneous form has exactly one solution. That is x sub 1 equals x sub 2 up to x sub n that is equal to 0. And then the last statement, the determinant A should not be equal to 0. At this juncture, let us discuss nonlinear equations. The general systems of two nonlinear equations are f of x and y is equal to 0, and then g of x and y is equal to 0. One method of finding the solution of nonlinear equations is by graphing. If we graph z is equal to f of x and y in xyz space, then the solutions x and y of f of x and y lie on the intersection of the xy plane, and the graph of z is equal to f of x and y. This intersection is called the zero curve of f of x and y. To define, let x sub 0 and y sub 0 be an initial guess for a solution. Alpha is equal to c and eta for f of x and y and g of x and y. The graph of z is equal to f of x and y is a surface in xyz space, and we approximate it with a plane that is tangent to it at x sub 0, y sub 0, f of x sub 0, and then y sub 0. The equation of this tangent plane is z is equal to p of x and y, with p of x and y is identical to f of x sub 0, y sub 0 plus x minus x sub 0, f sub x of x sub 0, y sub 0 plus y minus y sub 0, f sub y of f of x sub 0, y sub 0. Using the notation, f sub x of x and y is equal to partial derivative of f of x and y over the partial derivative of x, and then f sub y of x and y is equal to partial derivative of x and y over derivative or partial derivative of y. The partial derivatives of f with respect to x and y. If f of x sub 0, y sub 0 is sufficiently closer to 0, then the zero curve of p of x and y will be an approximation of the zero curve of f of x and y for those points x and y near x sub 0 and y sub 0. Its zero curve is a straight line because the graph of z equals p of x and y is a plane. Let us take this example. Find all the solutions of f of x and y, which is identical to x squared plus 4y squared minus 9 equals 0. And then g of x and y, which is identical to 18y minus 14x squared plus 45 equals 0, using graphing and the numerical methods.